Hello and welcome back. It's great to see you all again. Please say hello in the comments so that I know who's here. I hope you've had a good week. It's been quite a long week, hasn't it? But I hope you had a good one. I hope you've managed to get some work done and that you've got out and done some walking or whatever. Please say hello in the comments. It would be great to see who's here. Hello, Harry. How are you? How has lockdown been treating you? Tudor, hello. Nice to see you. James, hi. Well, this is good. I didn't realise last time round there were actually 50 people, one or two who I would rather not have had, but there were 50 people who were lurking around. That's really good. Do say hello, and it's great to see you. I hope you're all doing okay. It's an extended bit of weirdness, isn't it? I think we're all coping with it in our own way, and I hope you're managing to do the best that you can. Hi, Path. How are you? Hi, Zakir. Lovely to see you guys. I'm guessing you've had your mock results day, haven't you? I hope it brought everything that you wanted. But I guess part of doing this is that maybe it did, maybe it didn't, but let's try and get the grades up as best we can between now and the end. You've enjoyed your lockdown. Harry, what have you been doing? What's your secret? I do have a slight guilty pleasure that I've engaged in, which is I bought myself a PS5, which I'm very excited about. I actually, I bought my son an Xbox One a couple of years ago for Christmas, and I was kind of hoping that I would get to have a go on it, but never happened. And he makes such horrible squawking noises when he plays first-person shooters that it had to go upstairs. I couldn't be doing with it. No, joining the live stream doesn't help bring it up, but we've basically put in line that once you'll be noticing that you're doing wired and wireless networks now in class, and then at the end of that there'll be an assessment, and then we'll be doing system security and there'll be an assessment. So this is kind of getting ahead of the game, is that I want to cover in half an hour, and it'll be half an hour today. I don't want to keep you looking at a computer screen any longer than you absolutely have to. And this one, I just want to try to get through it with you, but it's just to give you a bit of extra information and for you to ask and figure out what you do and don't know. And that way, when you're looking at your revision guides, you've kind of got a much better sense of it. So will it help bring your results up? Not because you've attended, but because you understand more of the topic. So when you do your assessment, you'll know what's going on. All right. So I will crack on with this as best I can, and we will get on. Brilliant. So let me get to my presentation. I shall whiz through this. I've got as many questions in there as I can. I have some new tools to remove annoying people today, done a bit of research, which is very, very good. So hopefully it should ensure that we only have people of a certain quality watching the stream today. We shall see. Who knows? It's a bit like the Wild West, isn't it? YouTube. But anyway, let's crack on. So here we are, system software. Let's see what I can do to get through this and to make it exciting. If you've got questions, I'm making it exciting. I'm going to struggle with, but this is something that crops up again and again and again, and people tend to answer questions quite badly on this because they're just not, how can I put it? They don't give enough detail, and they tend not to be secure enough in the answers that they give. So we're going to look at operating systems today, and then we're going to look at the rest of the utility software next time, okay? So overview, and this is system software. You've got two flavors, and we'll come to that in a second, but fundamentally, system software allows a computer to run and to be maintained and to multitask. And that is, the multitasking thing is important. But without an operating system, a computer's going to struggle to operate at all. Hi, Nathaniel. How are you? Nice to see you. Yeah, good to see you. So that is what it's all about. So tell me, what does the term system software mean? I did just tell you. So what does the term system software mean? Anyone remember? Those three things, did that stick inside anyone's head? The three things that system software did. Yeah, Zakir, allows a computer to run. That is good. That is excellent. Let me try to reward you appropriately. Yeah, virtual code, yeah, allows computer to function. It can't do anything. You're absolutely spot on, Path. It can't do anything without an operating system. It's sort of something we take for granted because we're so used to using it. So it allows the computer to run and to multitask and to be maintained. So that's the kind of opening gambit. And it's that thing that, when I marked your mocks, it was so frustrating because you all know quite a lot about computers, but you just weren't precise enough with some of your answers. And that was one of the areas. So the three things there. This idea of sharing nicely, and this sharing nicely is actually from quite an advanced textbook that because computers share system resources. So, for example, you've got memory, and memory's got to be allocated to different programs, to different applications. All right, yeah. So that's what it does. The programs run thanks to the operating system. It cannot run without it. So that's what an OS tries to do, is tries to share things nicely with all the programs that compete to use it. So it controls the hardware, it controls the internal and the external hardware, and it communicates with the hardware using device drivers. I want to go into a little bit more detail about device drivers because we all know a little bit about device drivers. They're quite annoying when you don't have the right one because things don't work. But let's actually think about what a device driver does. And that's what we're going to have a look at today, is what a device driver does and how it helps a computer to run. So the operating system communicates with the hardware and with the application software. And of course, that's where the word apps comes from, is application software. The point here is the software cannot communicate directly with the hardware. That's what the OS is there to do. It's a kind of middleman between the two. And that's the purpose of the operating system, is that it sits between those two layers, if you like. This diagram, I hope you understand. So you've got the user, and that is you sat on the top there. And then you've got the user who wants to use any variety of programs, Photoshop, Word, Excel, PowerPoint, whatever, okay? And then you've got the operating system underneath it. You've got three main flavors. You've got Mac OS X, you've got Windows, and you've got Linux. And that accounts for 90, I'm guessing, but 99, 98% of OSs everywhere. Linux is a hugely popular system. But then underneath that, you've got a couple more things going on. With the operating system, it needs the device drivers to be able to communicate with the hardware. If you notice that when you upgrade your OS to the latest version of Windows or iOS or whatever, some of your apps drop off and stop working, and then you need to find device drivers to actually make them work. So there's that kind of sense that device drivers actually link between the two, okay? Now, you see the other box we've got there, other operating software. That we're going to look at next time, and that's that utility software, which is the security, the disk organization. Maybe you've had to wipe your disk, compression for making files smaller. We've talked about compression, we've talked about two sorts of it, all of that stuff. And then we've got file backup. So that's the utility software that we'll look at next time. But I'm simply going to focus on operating systems today, on operating system software. It is vital. Without it, the computer can't run. So let's look at device drivers. They are code. That's all it is. It's code. And it's code that's written to allow the operating system to speak to the hardware. If you think about it, if you didn't have device drivers, every application that's written would need to be written so that it could speak to every single piece of hardware that exists. Well, that's just impossible. So it's much easier to cut out the middleman and to make an OS that does all of that for you. So you'll typically upload the driver to your OS. So say, for example, you plug a new camera into Windows, and Windows will go on the internet. It'll find the latest driver. Say you've put a Canon or a Nikon camera, you've plugged it in. It'll go and find the latest driver on the Nikon site. It'll know where to go because it's a routine that's been set up, and then it'll get the thing working for you. Okay, so device drivers actually have a really fundamentally important role to play. They allow the operating system and the hardware to communicate. That is how they communicate. And also, because otherwise it would just be impossible. So drivers often need to be updated, either to improve performance, to make the computer run more efficiently, because that is what the OS is trying to do, is to make the computer run efficiently. It wants to fix bugs, and it wants to respond to, say, for example, I don't know whether I use Macs generally. I use PCs at school. I use Macs here. There's a Big Sur. That was the latest Mac OS. and a lot of my apps just stopped working because they were too old. So I had to update some of those. Some didn't work, and it was new drivers that was required to communicate with different bits of hardware. Okay, so I hope that all makes some sense to you. Let's get rid of that. Excellent stuff. So, what games do you play on PS5? Well, I have discovered, much to my shock and horror, that actually I need to take out a second job to afford any of the games on PS5. I don't know what they're thinking with 70, 80 quid for a game. That's just absolutely crazy. I, at one point, like to do the Call of Duty stuff, but I'm just too slow. I can't be doing with faffing around with changing my guns and having to throw grenades. I end up just blowing myself up. It's too much. I like driving rally cars, so I've got myself World Rally Championship 9. It's a bit sad, but I quite like driving cars quickly, so that really pleases me. I might have a go at FIFA just so I can beat Tottenham, because the only way it's going to happen right now, so I might do that. Shame about Liverpool being knocked out of the FA Cup, wasn't it? Yeah, so I don't know. What are people's favourite games on Xbox or PS5? That would be quite interesting to know, actually. I've bought a couple of things. I decided not to buy Miles Morales because it just looks a bit. It looks good, but is it actually a good game? I'm not convinced. So, what else have I got? I can't think. It'll come to me. Yeah, stick your favourite games in there. That's quite interesting. To fix bugs, right? Excellent. So that is what device drivers are for. So the question is, the CPU sits between the user's application and the hardware. What is meant by this statement? Can anyone, pro clubs, what's that one for, Darren? I don't know that one. Yeah, Apex, don't know. Yeah, Minecraft. Do you know, this sort of sandbox games, I don't really see the point. And also open world games, I can't be bothered to walk around. My son's playing Red Dead Redemption, and there's so much just walking around involved. I was having a look at Cyberpunk, but I'm not sure they've actually finished the game yet. But again, 70 quid. 70 quid for a game? It's a lot of money. So anyone care to throw an answer at this? The CPU sits between the user's application and the hardware. What is meant by this statement? Don't worry about whole sentences. Can anyone think, it's a 3-mark question, anyone think what this might be trying to get at? Anyone think what we're trying to get at? Let's have a look. I'll tell you what, I will give you, it's funny, I've set this up to be ultra low latency. It's still really quite laggy, but anyway, it doesn't matter. Let's have a look. What have we got? We've got Luke. Hello, Luke. It allows the application software to access hardware. Yes, it does. That's exactly what it does. That is delightfully accurate. Tudor converts the user's input into binary instructions for the hardware. Yes, it does. It does do that. Okay. Furious Racing. I was really stuck between Dirt and WRC9 actually, but I'm a bit of an anorak, so I quite like. I thought Dirt was a bit like Need for Speed, and I don't want people walking up to me, issuing me with instructions to race. I just can't be bothered with that. It's all a bit gimmicky. CPU, it is the middleman, absolutely being the apps and hardware. Yeah, it's a Zakia, that's absolutely spot on. And Path, you completely nailed it, actually, guys. So these are the 3 sentences. Apps can't communicate with every hardware device that exists. If you think about it, it's totally inefficient for that to happen. Because otherwise, if you're writing an application, you've then got to consider every single piece of hardware on Earth. So that's why you've got device drivers, because it's an easier way to handle it if the OS does all of that. So that's what happens. And the OS sits between the two, which is, someone always said that exactly. I think it was, yeah, it was Path. Absolutely spot on. And Luke, that's an excellent answer. If you make the test, could these questions be put in? Do you know what, though? In all honesty, the questions that I'm asking, there's such a limited amount they can actually ask you on this topic. But it's just a question of being a bit more precise and getting your head around exactly what these different components do and how it works. So that's the answer. The kernel. Now, this isn't actually necessarily going to be in any test that you do. But I thought this was quite interesting because if you've ever had a computer crash and you get that screen that shows the code of what's happened, it often talks about the kernel. And I thought it'd be useful just to say to you that the kernel is a program and it's responsible for memory management, process management, and task management, which is the most fundamental sort of operations that have to happen. That's what the OS is doing. It's looking after memory. It's managing the processes that are happening, and it's managing the tasks. And it's looking after the most low-level hardware operations. So the kernel is this app, this piece of code that's used by the OS to connect the hardware to the applications, to the apps. Okay, so that's what the kernel does. And if ever you've looked at a crash screen, that is very likely what you're going to see. Some reference to the word kernel. I'm not going to make you tell me the answer for that, but that was what it did. It's at the core of the operating system. The kernel is that piece of code that looks after these low-level operations. All right? Okay, user interface. This is what an OS does. This is the Zakia, you were asking me, could these questions be in a test? Not to have anything that I've asked today in any test that we gave you would be impossible. Obviously I'm paid to do this, but I look through the answers to past paper questions, and it's quite a small pool that they're drawing from each time. There really aren't that many things they can ask you. So what does the operating system provide? It provides a user interface, and I'll talk about that in a second. Memory management, to manage the memory of the computer. It manages the peripherals. A peripheral might be a printer. A peripheral might be a hard disk drive. User management, which allows users to have their own accounts, which allows users to have access to certain things and not certain other things, and to stop things being written over. And also file management. You know about saving files, putting files in folders, and knowing where the files are. So when you actually want to get them, the operating system knows where they are. That word looks like it's not spelt right, but it is management, yeah. Okay, so quiz. Who can remember any of those things that I just said? Can anyone try and write down those 5 things? This is an absolutely vital one that tends to appear again and again and again. Can anyone think about any of those? Yeah, file management is one. File, user, process management, user interface, peripheral management, and file management. I think we are sorted. I think that is good. That is excellent. Hi, Ahmed. Nice to see you. How many have we got? We've got 20 something on at the moment. No, I've got 18 people. Okay, that's good. So yeah, I think you've absolutely got everything on there completely. Actually, let's have a look. Let's have a look at that one there. User interface, memory management, peripheral management, user management, and file management. You could add security to that as well, but that's kind of covered within user management, which is why I didn't put it on there. So let's speed up now, because this stuff you know, but this is stuff that you're going to have to learn for when we test you on this at some point in the near future. So the way it's going to work, because we know you haven't got your final exams, so we're still waiting, by the way, for the government to actually tell us how we're going to manage this. And what teachers are supposed to be basing marks on, but it's not rocket science. It'll be based on the mark on everything you've done and what you do between now and the end of the term. That's the logical way this will happen. So these are the sorts of things that you're going to need to know when you get assessed on this. Graphical user interface, often called GUI, the GUI. WIMP, Windows icons, menus, pointers. And I know you're thinking, well, that's obvious, but actually they're relatively recent graphical user interfaces. They were only just coming out when I was... when does school start? Well, don't know. It'll start when the R number is low enough for the government to know that they haven't got to pull you out again once we start back. So, and I think that's part of the problem, isn't it? Is the uncertainty of knowing when we're actually going to be back. But I don't know, Zakia. It would be nice to know, wouldn't it? I think that uncertainty feeds into it being quite stressful sometimes. Windows, icons, menus, and pointers. Obviously, the Windows, it's called Windows because look at it. It's a series of windows. Those rectangular things are windows. The icons are the things that you click on. The menus, the drop-down menus where you select one from a list of things, and the pointers are the cursors where you click, where you move your mouse and you point at things. You've obviously got another type of interface, which is the touch screen, which is used by... Wow, Nathaniel, you miss school. Do you know what? I think we all miss school, to be honest with you. It's because it's not just the lessons, is it? It's actually seeing all your mates. It's the routine. It's quite hard, isn't it? So two sorts we've got here. We've got the GUI, and then you've got the touch screen that you might have with iOS or Android, and that's where you've got the gestures, and you can pinch, and you can drag, and you can flick rather. So you've got two types of interfaces there. You've also got this one, CLI, command line interface. Whenever you see any kind of a film that involves hacking, they're always at a command line interface. Command line interfaces have got this command prompt, which is that sort of chevron. It's the greater than sign that you see, and then you type in the code, or you type in the instruction that you want to carry out on the code. So this involves knowledge. The user enters commands. It tends to be for advanced users because you need to know what the commands mean. But it does give you more direct control over the computer. It's more powerful, it's harder to use, and it's more efficient. You can also use it to run routines. It's or sort of macros, you could say, but it's a more effective way of actually doing anything. But it does require advanced knowledge. So there's always room for a bit of a 5 marker on command line interfaces, and to get you to compare these different interfaces, ways of accessing the computer. Okay, this one you've seen before. This is a menu-driven interface, and this is on simple devices, but it's also on cache points. So on a cache point, you've got a very limited number of things that you can do. You can enter your PIN, and then you can see it's got 1, 2, 3, 4, 5, 6, 7, 8 different buttons. So it's only ever going to give you a maximum of 8 different activities that you can carry out. This is what early mobile phones were like before Apple released their first phone. That you would go through the menus. If you think about a simple game, or if you had a go on an 80s game or a 90s game or an early iPod or MP3 players, this is what they look like. You've got a limited number of things. I mean, you can think about a washing machine as the same thing with an embedded device, yeah? So earliest mobiles cache machines, it offers limited functionality, but also it's when you only want people to be able to do limited number of things. On a cache point, you don't want people hacking in and nicking money. Well, no, you just don't want that happening, do you? So, question for you. Which interface is this? Requires the use of written commands. Which interface is that one? Okay, Path has nailed that. That is outstanding. That's exactly what it is. So it is, let's go on to the next one here. It's the command line interface. So you've got to write commands. It's difficult to use, it's hard to master, but it's powerful and it's useful. So it's a very useful thing to use. And in fact, you can save an awful lot of time doing it. All right, so let's go on to the next one and let's speed up. What about this one? Which interface is this? Useful when you want to limit what the user can do. Can anyone remember what that one is? Elvin, well done. Recacy, well done. Ahmed, well done. Possibly James, well done. That's good. Luke, CLI, yes it is. You all absolutely nailed that. Yeah, menu-driven Path. You absolutely nailed it. That was very, very quick. So let's me push on. Oh, Path, I've got to give you oh my word, I've got to give you some kind of a reward for that, which is going to be a random sound. I think it should be... Oh, I think it's going to have to be... I'll tell you what. Question for you. Which film is this from?
What is he doing?
He's beginning to believe.
Any ideas what film that one's from? A lot of command line interface on that film. This is getting slightly off topic here. What about this one?
Billions of people just living out their lives, oblivious.
Ooh, Bart, that was quick. It is The Matrix. It's one of my favourite films, even though it's quite tacky. I think it's a great film. I do wonder at the moment if we are, in fact, living inside it. Who can tell? So which interface is this? You're absolutely spot on, menu-driven interface. And what about this one? It's the last one. So very intuitive for the user, making it a simple user experience, providing the users with a great deal of control over the computer. Can anyone remember? Matrix 1 as well, Bart. That was, the other was, there were three in total. The other two were dreadful. They were, graphical user interface path. You're absolutely spot on. That was exactly what it was. I think I shall have to ask you another film. Yeah, that was very impressive. I have to ask you another film-related question on that one, which I'll do in a minute. Okay, let's push on with the next thing while we can. Here we go. Graphical user interface. Woo! What does WIMP stand for? The third one was bad. Yeah, you're absolutely right. It was bad. Yeah. What does WIMP stand for? It's not abusing anyone who I teach or any of your friends. I thought I'd get there before you. Does anyone know what WIMP stands for? Windows icons, menus, pointers, absolutely spot on. Well done, Luke. That's brilliant. Really, really good. That is exactly what we want. That is a very good answer indeed. And so the question for all of you then is, which film is this one? Bart, you nailed it too.
I didn't know how this machine worked.
I'll play that for you one more time.
Sorry.
Which film?
I didn't know how this machine worked.
If anyone can remember what was happening when that was said, an extra bonus point. One more time for you in case you didn't quite pick it up.
I'm sorry. I didn't know how this machine worked.
Yeah, but you have nailed it again. It is Guardian of the Galaxy, and that's the point where he was having his photograph taken and he stuck his finger up at the person who was taking him into custody. Right, WIMP, brilliant. Windows icons, menus, pointers, fabulous. So memory management. All apps run in main management. We know the story, right? You've got main memory, primary memory, which is your RAM, and everything that you're using, the operating system gets loaded into RAM when the computer boots up, and then if you want to load any more programs, you load them into RAM. All right. So we know that's the story. The operating system manages where the app is stored in RAM, and where any data that the app needs is stored in RAM by allocating memory. So memory allocation is one of these key tasks that the OS does. Peripheral management, it manages hardware components that aren't part of the CPU. The CPU does its own thing, okay? So for example, hard disk drives, input-output devices, keyboards, mice, and so on. So that is what the OS is responsible for. So it's actually got quite a big job. Okay. Yes, this is quite good. I discovered a way of stopping people putting in offensive language. I Googled, and there were some lists of all the swear words known to mankind. It was one of the funniest lists I've ever read in my life. It was very long. It was thousands of words. I learned some new things myself as well. It was extraordinary. Right. Okay. File management. So we know that you store your stuff, your data in files, and the files get stored in folders, and you can put folders inside folders, therefore subfolders. An operating system allows you to create, modify, delete, and move files. Now, this is one of those things. Yeah, I will put it on Google Classroom, Bart. I will do it. And Path, you asked me last time to send you the mind map, which I haven't yet done. And I'm going to, but annoyingly, I found a mistake in it, and I couldn't send it out with a spelling mistake. So I will put that on there for you. This is quite handy because I've worked through several PowerPoints and been through all the books, and I've kind of adapted it just to make this hold exactly what you need to know. So OS allows you to search for a particular file. We're still in file management to track the location of a file, because obviously if you save something somewhere, something somewhere in the index needs to know where that file is. When you want to find it again, you can just open it. 59, right, I need to push on and get this done in 10 minutes. So you can restore deleted files like from the trash bin, from the waste paper bin, and it prevents the conflict. So in the last one's referring to, you've got a network and you've got a file which is trying to be accessed by two people at the same time. And the OS will manage the conflict that occurs when people want to open the same file at the same time. All right. User management. Now, this is where on a computer you can set up multiple users. So the network admin sets up access right for the user. So, for example, I've given, my son's using my laptop during the day. I've given him a log on. That's his log on. And he's got access to whatever's there, but he's not got access to my files because he doesn't need to see them. And he could delete them, and that would be annoying. So you can set up access rights depending upon the user. And of course, in companies, that's what happens. You've got different levels of access to SIMs depending upon what you do at school. I wouldn't have need to have access to the payroll system, but the people that do payroll do. I mean, it'd be nice to know what everyone else earns, but I don't need to know it. So it gives you permission to access and this idea about read-write files, for example, when you're on the shared area, everything there is read access for you. So if you want to download it and then use it, you could do, but you can't overwrite it. Whereas stuff on your area, you can save stuff to there. So that's the whole idea of read-write. Some files are read and some are write, and you can have read or write access to files or folders. It means that users can be identified, so you can see who has logged onto the system. When they logged off the system, you can also log them off the system, and you can set default login times. Okay, user management, multitasking. I've got an octopus there, so I'm not even sure if octopi can multitask, but I think they've got several hearts, 2 hearts. And I think their brains are in their legs or something. I could be making that bit up, but they're quite interesting. So multitasking, it's quite interesting because people used to say computers can't multitask, but actually now that you've got multiple cores, actually computers can multitask. But computers have always given the impression of being able to multitask, even though one core can only do one, in any one cycle, they can only be doing one activity. But because it's managed by the operating system, it appears to be multitasking. So what does it do? It gives the applications access to the CPU and memory, and the operating system divides the CPU time between the applications that are open. So in this scenario, you've got PowerPoint open because you're making a presentation on something and you're flicking between PowerPoint and Chrome. And you're going to put into Chrome, you're copying something, and then you're copying and pasting it into PowerPoint. So it needs to be running all of these things. You might have some kind of media playing on another application. You listen to music. So the CPU is going to look at all of these things running, and it's going to work out the most efficient way of keeping everything running by prioritizing certain processes and certain functions for instructions ahead of others. And of course, it'll use virtual memory when necessary. And we know that when RAM gets full, the OS will then use a part of the hard drive as RAM, which is slower, and it will move the instructions and applications that are being used less often from RAM into the virtual memory on the hard drive. There we go. Okay, question. Using an example, explain why an OS is essential when running on a computer. Using an example, explain why an OS is essential when running applications on a computer. And this kind of breaks down what we're looking for there. Let me give you 30 seconds to do that. It also gives me a chance to have a drink of water. I can see a lot of nothing happening in the comments, to be fair. Well, obviously, dub's not your thing. Oh, here we go. Hardware cannot communicate the software by itself, so the operating system works as a middleman. Ooh, that is very, very good. Yeah, that's definitely going to get you 2 marks there, Tudor. That is outstanding. Luke, when trying to print a document on Word, the application is able to access the hardware printer. Instead, it contacts the OS, which is able to access the printer hardware. Excellent. And you could potentially have squeezed something in there, Luke. Very good answer, both of you. You could have squeezed something in there about device drivers, I dare say. Those are two really good answers. Let's push on. What do we got? We've got Bart. It needs to bridge the gap between a computer user and the hardware they're attempting to use. For example, moving your mouse to change it. But yeah, point of view, absolutely spot on. That's really, really good answers. Yeah, I got that. That's good. That is excellent. So you can see, without an OS, applications can't communicate with the computer's hardware. There's that point of the OS being necessary and what it's necessary for. The idea that it bridges the gap, it gets the applications and the hardware working together, and it uses the kernel to do that. So without an OS, and you give your example, this is something else. Got so annoying marking your mocks, and you would. Because if it asks for an example, it needs to see an example to get that second mark. It was so frustrating. It was so bizarre that you guys did worse on paper 1 than paper 2, but you always find paper 2 more challenging. And it was reading the question and thinking, okay, I need to say what it is and then give an example. I think sometimes you didn't put answers down because they seemed too obvious, but I think you more or less covered that there. That is good. Right, memory management. What have we got? 05. I'm not going to go on beyond 10 past because life is too short. The operating system manages the RAM. When you load an application, the operating system copies the app into the RAM. We know that. I've talked to you about that. Did you find it easier overall? Do you know what, Bart? The paper 2 that you had as your mock, I thought in paper 2 terms was actually not a bad paper at all. There wasn't anything that was too dreadful. I think sometimes the wording of paper 2 is what throws people. But yeah. You find it easier over, yeah. Okay, so yeah, and it manages virtual memory. I've kind of covered that. We talked about that. So I'm not going, what does the OS do with peripheral devices? It controls them and it gives apps access to them. Let's not repeat ourselves. What does GUI stand for? It stands for Graphical User Interface. What else have we got? If you're writing a document and you press print, how does the program now to communicate with the printer? We've kind of covered that already. Library of device drivers. OS uses appropriate device driver to allow the application software to communicate with the printer. So think about that role that the device driver does. The device driver has information that's required for the OS to effectively communicate with the hardware or the application, okay? Or to allow the app to communicate with the hardware. Ta-da! How far did I get? 1907. So that was 37 minutes. Well done, those of you who stuck through it. It's been an absolute pleasure. If any of you got any questions, I'm happy to stay here for a moment or two to answer them. But if not, I will see you at the same time next week. 37 minutes. I'm going to try and make it 30 next time. But if you want to stick around, you want to ask some questions, I'll be here for a moment or two. But if not, you're welcome, Path. Have a lovely week. You're welcome, Harry. Have a good week. It's been lovely to chat to you all. Yeah, I kind of miss teaching you guys. I've got to say, it's not the same. Sad, blinking. Elvin, you're welcome. Luke, you're welcome. Recacy, if that's how you say it. Thank you. You're welcome. Darren, you're welcome. Guys, bye, Path. I'll see you next time. Okay. Let people know this is what we're doing, and I will put those PowerPoints onto somewhere and I will get that information to you. I'll send it to you via Show My Homework and let you know where it is. In fact, I can just put it on Show My Homework, can't I? Because I've got you all set up there. So that's what I'll do. Yeah, but that's a really good question. I don't know. Because it's parents' evening tomorrow, so I'm going to be going. I'm going to be kind of going through people's papers a bit there, but the parents' evening is quite handy because you do get 5 minutes and you get it when it's time for you to have it, but it's not enough time to really go through things in detail. So I don't know. I will speak to school about that because I know that you do want your papers back. Yeah, because emailing it's going to mean scanning it in, which, that's a good question. And it has occurred to me that you do desperately want to see your papers, and I'm not quite sure how we're going to do that, but I do think that you need them back because it's going to help you revise, isn't it? So it's a good question. I'll take that one forward. I will try and get you an answer for that one next week. In fact, I will write it down. Papers back to students. Okay. All right, that's a good question. All right. Okay, guys, I will leave you to it. No problem at all. and I will see you all next week. Have an amazing evening. Arsenal are playing in 1 hour against the mighty Southampton, so I shall enjoy that. See you all next week. Have a good one, guys. Bye-bye. Bye-bye.